Hey, I'm going to tackle the last two questions from the first water potential worksheet. So a plant cell with a solute potential of negative 7.5 bars keeps a constant volume when immersed in an open beaker that has a solute potential of negative 4 bars. What is the cell's pressure potential? Pressure potential. So remember that if these are isotonic, constant volume, then the water potential of the cell is going to be equal to the water potential of the beaker. And the water potential of the cell is negative 4 bars. Okay? And so, the beaker, remember that the beaker here has a water potential that is the solute potential plus the pressure potential, 0, and the solute potential is negative 4 bars. So that's how we get that the water potential of the cell total has to be negative 4 bars, because the water potential of the solution is negative 4 bars, pressure potential is 0 in an open beaker. So there we go. Now, the water potential of the cell is equal to the solute potential of the cell plus the pressure potential of the cell. And since we are trying to solve for the pressure potential, we can subtract the solute potential. So water potential of the cell minus solute potential of the cell is equal to the pressure potential of the cell. The water potential of the cell is negative 4 bars. Minus the solute potential of the cell is negative 7.5 bars. The two minuses together turn into a plus. And so negative 4 bars plus 7.5 bars is 3.5 bars is the pressure potential of the cell. The cell has a pressure potential of 3.5 bars. Okay, and then the last question, question 7. At 20 degrees Celsius, a cell containing 0.6 molar glucose is in equilibrium with its surrounding solution containing 0.5 molar glucose in an open container. And so again, we have to find the cell's pressure potential. So again, remember that the water potential of the cell is equal to the solute potential of the cell plus the pressure potential of the cell. And the water potential of the cell is also equal to the water potential of the solution. Okay? And remember that the water potential of the solution is the pressure potential plus solute potential of the solution. Pressure potential is 0 because it's an open container. So water potential of the solution is basically the same as the solute potential of the solution. And so for this one, you do have to calculate negative ICRT for the solution. And since this is glucose, that's negative 1 and 0.5 moles per liter. And 0.0831 bars liter per mole Kelvin, and then 293 K. And so the solute potential of the solution, which is the same as the water potential of the solution, is negative 12.17 bars. Okay? So we're there so far. And that's going to be equal to the water potential of the cell because the two are isotonic. So if the water potential of the cell, we know that, and we can calculate the sucrose potential of the cell, and that will give us the pressure potential of the cell, which is our unknown. So the water potential of the cell is negative 12.17 bars. And then the solute potential of the cell is going to be negative 1 times 0.6 moles per liter times 0.0831 bars liter per mole Kelvin times 293 Kelvin. Okay. This is, remember, equal to the pressure potential of the cell. Sorry, my two sides are running into each other. Negative 12.17 bars minus negative 14.6 bars equals the pressure potential of the cell, and so that's going to be 2.43 bars equals the pressure potential of the cell. So the pressure potential of the cell is 2.43 bars. So I hope this is helpful. Please let me know when you have questions.